So we would like to find the line along which the two given planes intersect. And first of all, let's try to understand why these two planes intersect. The reason is because they have a normal vectors that we can easily find. So what would be the normal vector corresponding to this plane? We just look at the coefficients of x, y, and z. So a normal vector for this plane would be 1, negative 1, 1, and a normal vector for this plane would be 1, 1, 1. We can clearly see that these vectors are not parallel to each other. One cannot be a scalar multiple of the other, which means that the two planes will eventually look like this. So they will intersect. Now, one way to find a parametric equation for the line, this line along which the two planes intersect, is to just find 2 points on it. And we find 2 points on it by solving the system. However, there is a very nice thing that maybe we should keep in mind and use it, that if we take the normal vectors to the planes and we take their cross product, then their cross product is actually parallel to the intersection. So in other words, what I'm saying is by taking the cross product of this vector and that vector, we will find the direction vector for the intersection, and then we need to find just 1 point in the intersection of the two planes. How do we find points in the intersection of the two planes? Well, we have a system of 2 equations. So that would be this system with 3 unknowns. Usually, we find a unique solution when we have the same amount of equations as unknowns. And here, what we need to do is just take one unknown and set it arbitrarily equal to a number and solve the system that comes up from the other equations. It cannot necessarily be done with any unknown, but if we play around a little, we should be able to do that. And we're going to show all the details now that we have a plan for the solution. So let's take a look now at the solution in a systematic way. So the first thing is we will find a direction vector for the intersection. And this will be simply 1, negative 1, 1 cross with 1, 1, 1, which is I, J, K, 1, negative 1, 1, 1, 1, 1, which is, so delete the first row, the first column, and you will get negative 2. Delete the first row, the second column, and you will get 0. Delete the first row and the third column, and you will get 2. So this is a normal vector. And now we need a point of intersection. And here's what we do. So we put the 2 equations together into a system. And let's set, for example, z equals 0. I want you to notice that, for example, if we chose y to be 0, we would get a system that has no solution. And that was the point that I was trying to make before. But if we set z equals 0, then we will get the system x minus y is equal to 3 and x plus y is equal to 5. If we add the 2 equations, we will get 2x is equal to 8, which means that x is equal to 4. And if we plug 4 into the first equation, we will easily get that y is equal to 1. So what is the point that we have got? it's the point 4, 1, 0. And now we have a direction vector, we have a point, the intersection will have parametric equation that can be given by, so we vectorize the point, so 4, 1, 0 plus t times negative 2, 0, 2. We can leave it like this. You can certainly rewrite this as 4 minus 2t, 1, and 2t. And that's the parametric equation, or a parametric equation for the intersection. Thanks for watching.